Hi guys, so let us go ahead and look at an example where we will have to use a double angle formula, right? So let us go ahead and start by reading the question. It says, if A is an acute angle and sine A is equal to 0.6, determine the value of sine 2A without using a calculator. Right? So we know that this form sine 2A, it's a double angle formula, right? It relates to this 1 over here. So we're going to use this to expand out. So sine 2A is equal to 2 sine A cos A, right? So we want to solve this without using a calculator. So it's going to be 2. We have sine A, but we don't have cos A. So if they're saying without using a calculator, how can we solve for cos A when we have sine A? You guessed it, we use our cost diagram. Remember, you use a cost diagram when you're working with trig ratios. It's going to be your best friend, like I've been emphasizing. All right. So firstly, let me write here at the side. We're given that sine A is equal to 0.6. So there are two ways you can look at this. So when you're given a single digit like this, 0.6, it's like, but the form for sine A is equal to either y over r or opposite over hypotenuse. But we only have one number, so what do we do then? The first situation in which you can look at it is you divide that number by 1, because essentially anything divided by 1 is going to be that number. So now you have your y and your r, where your r is 1 and your y is 0.6. So your 0.6 is, like I said, y, or your opposite, if you can look at it like that. And your r is your hypotenuse, which is going to be 1. So if you see that you have a single digit, immediately divide by 1 to make your life easier. So if we're going to draw this, we know that the hypotenuse, the radius, stems from the center. You just draw it anywhere there. So they say this is an acute angle. We know that an acute angle is less than 90 degrees. So it must be between 0 and 90 degrees. An acute angle is an angle that is less than 90 degrees. So we must be working on this quadrant. So yes, this line you could have drawn it there or there. It doesn't matter as long as it's, in this quadrant. And we know that to complete the triangle, we pull this line down so that it can be perpendicular to the x line. This is the x, this is the y. Perpendicular in that it makes a 90 degree, right? So like I say, these two ways in which you can look at this. It's 0.6 over 1, so 0.6 here, 1 angle here, because it's opposite over radius. That is correct. Or you can notice that, hey, this 0.6 can also be written in a fraction form, right? Let me go ahead and erase this. We know that 0.6 is equal to 3 over 5 when written in fraction form, right? In this case, yes, they say without using a calculator, but if you didn't know that you could just type 0.6 into a calculator to say equal, it's going to give you 3 over 5, right? This is how it can be written in a fraction form, which makes sense because it's not a recurring. Okay, even recurring numbers can be written in fraction form, such as 1 over 3, but you must just know that 0.6 is 3 over 5. So in this case, yes, you can either use this form or you can use this form. But let us go ahead and use this form. Typically, when you deal with triangles, you don't want to involve decimals, you know. Yes, you want to be working with whole integers. But I mean, if push comes to shove, you can just use this. You can use 0.6 divided by 1. I don't think you will be wrong. But just try to make a habit to convert some of these decimals to fractions. If they cannot be converted to fractions, then you can just use this method over here, this first one, where you just divide by 1, where you divide that decimal number by 1. So always try to check with your calculator, can this number be converted to a fraction? If yes, keep with the fraction part then. And so with the fraction part, the 3 is the y, the 5 is the r. So meaning 3 here and 5 there. Cool. Let us go ahead and work with that part then. So we have sine A. We have sine A. But we don't have cos A. And we know that with cos A is equal to x over r. X is here. So x over r, we have r, which is 5. Right? And so how do we solve this x then? By Pythagoras, because this is a right-angled triangle. So 5 squared minus 3 squared is equal to x squared. Go ahead and square root everything. You'll find that your x is 5 squared minus 3 squared, which is going to be plus minus 4. Remember, when you square root something, the answer is going to be either positive or negative. But since you are working on a positive x line, it's going to be positive 4. If the triangle was flipped over to this quadrant over here, maybe they said it was an obtuse angle, then yes, it probably was going to be negative 4. But we are working on a positive x line, so we're sticking with positive 4. Very important to note, right? Cool. So inevitably we have cos A to be 4 over 5. So now we have both sine A and cos A. We can go ahead and substitute them here. So sine 2A is equal to 2. What is our sine A? 3 over 5. Our cos A is 4 over 5. Multiply everything out. What is 4 times 2? It's 8. 8 times 3. What is 5 times 5? It's 25. What is 8 times 3? It's 24. So your final answer is going to be 24 over 25. If you had kept with this form, you are going to get a decimal number, of which if you're going to convert, you are still going to get 24 over 25. So yes, you can approach this question in 2 ways, but you want to make sure that you leave your final answer perhaps in a fraction form. I don't think you will be penalized if you leave it in a decimal form had you went with this method, but it's always in your best interest to see if you can leave it in fraction form, right? Especially in without using a calculator type of questions. And yes, that is the first example of how you can use a compound angle formula to solve everything. Yeah.